All right, today we're going to introduce to you a new topic that you may have talked about a little bit in pre-calc when you found horizontal asymptotes, but haven't really discussed to any length, and that's called the limit of a function. Now, what is a limit? A limit technically can be defined as the intended height y of a function at some point x in the domain. In other words, it is kind of the y value that you get close to as you approach a particular x value. So you don't ever actually get to that point, but what y value are we getting close to as we do it? So here's an example. Let's say this first height, the top of this was at 5. If you think about what we're approaching from this side and what we're approaching from this side, both are approaching a y value of 5. So as we approach 0, at this random function, the y value we are approaching is 5. Similar situation over here. If this is 2 and this is 7, then our limit as we get closer and closer to the 2 from this side and this side in our random function is equal to 7. So, how do you determine a function from a graph? Look at the function f of x equals x squared, for example. The function changes height all the time throughout the domain. Let's look at 2. When x is 2, sometimes if it is a function that is smooth and doesn't do anything strange, it sometimes equals the value. F of 2 would be 2 squared, which is equal to 4. The limit as we approach 2, if we look what happens as we get closer to 2 from either side, we are approaching a y value of 4. So many times, the value and the limit at that point will be the same, but not always. For example, functions that do not reach their intended height. Maybe there's a hole, maybe there's an open circle at the end of a graph or something like that. For example, if I went to the trouble of plugging in a 2 here, we would get 2 minus 2 in the denominator, which is 0, and we are not allowed to divide by 0, therefore that would not be good. Instead, we could factor the top and see that our x minus 2's cancel out, which means this looks like the line y equals x minus 4 with a hole at 2. Which means, as we approach from the left, we would be approaching that hole that has a y value of -2. Oh, left would be the bottom one, because when it says 2 from the negative side, that means we are approaching from the left. 2 from the positive means we're approaching from the right. Similar thought from the right, if it's the line x minus 4 with a hole at 2, as we're approaching 2 and not actually getting there, we are approaching a y value of -2. This one, for example, h of x equals 1 over x. We can't plug in 0, not possible. There's not going to be any way to get rid of that x in the denominator. So, maybe we need to look at what this graph looks like. If you remember from step 1.2, when we talked about types of functions, you should know that 1 over x looks something like this. This first example, limit of h of x as x approaches 0 from the positive side, means we're looking at this section. What happens as we approach 0 from the positive side? You'll see that it goes to positive infinity. As we're approaching 0 from the negative side, like this next example, it approaches negative infinity. Now, when does a limit exist? A limit exists when the left-hand limit, up a little bit, the left-hand limit, and the right-hand limit are equal. So let's talk about these two that we already did. You notice up here, when we approach 2 from the right and 2 from the left, we got -2 for both. So that tells us the limit as x approaches 2, regardless of the direction of g of x, is going to be -2. And we know that because from the left it was -2 and from the right it was -2, and those are equal. 0, on the other hand, those limits are not equal. So the limit as we just approach 0, regardless of direction in this function, is DNE, which stands for does not exist. They don't exist if the limit from one side and the limit from the other side are different. Here's some steps to help you with the limit, and we'll talk more about these in class, but first step for finding a limit, plug in the intended limit value. So if we're approaching 1, try plugging 1 in. If you don't get division by 0 or a negative and a radical or something strange, then you're going to get the limit. 1 plus 2 minus 5 is -2. If you can't plug it in, notice how plugging in a 1 here would give us division by 0. Then we can do some algebra. Lots of times factoring, not always factoring, but oftentimes that will work. We'll talk about some other methods as we get deeper into this. Our x minus 1s will cancel out. We get x plus 3, then plug in the 1, and we end up with a limit of 4. If that still doesn't work, we can plug in points close to that value. And we have to check both sides, so we can't plug a 2 in here. There's nothing we can do to get rid of that 2. So instead of plugging it in, I'm going to plug in points like 2.1, 2.01, 2.001, 2.0001 into an XY table and see what these numbers approach. Now keep in mind, you are going to have to check both sides, so also check 1.9, 1.999, 1.9999, and so on to see what those y values approach. Both tables must be approaching the same thing for there to be a limit. Let's try some. F of -5 is simply asking for the y value at -5, and you'll see that it is 6. F of 2 is going to be 1. I know that the graph is up here, but we're looking for the y value, which is down below at the point. F of 4 is going to be at -3. You're looking for where the point is, not the open circle. We're going to do some of these. The limit as x approaches -7 of f of x. Let's talk about that. -7 is right here. We have to look, -7 is right here. We got to look at what it approaches from this direction and from this direction. They are the same. The y value that it is 2. Therefore, we know the limit as we approach -7 is 2 because it's -2 from the left and 2 from the right. So that's how we know they're the same. Let's talk about, I'm going to skip around a little bit. Limit as x approaches 4. Let's talk about 4 for a second. As we approach 4, from the left, we're up here. From the right, we're down here. So, are they the same? No, because they're not. The limit does not exist. Now, that doesn't mean that the limit doesn't exist from one direction. For instance, down here on number 8, And number 9, if we approach 4 from the positive side, that's just this direction. And notice that it approaches -3. They're only interested in the one direction. We don't have to check both. And from the left, that's going to be a +2. So, stop the video, finish up these examples, and we will talk about all of them tomorrow.